Let's jump right in. Welcome to this premium visual explainer. Today, we're taking a massive, chronologically mapped journey through one of the absolute most fascinating chapters in all of science, evolutionary biology. From the literal birth of the universe to the complex mechanics of natural selection, we are going to break down exactly how life came to be.
To really grasp a story this huge, we have to move chronologically. So here is our agenda. We'll start with the origin of the universe, then move to Earth's primitive atmosphere, the chemical origin of life, the famous Miller-Urey experiment, evaluating theories of life, and finally, Darwin and natural selection.
All right, part one, the origin of the universe.
So the accepted model for how everything started is, of course, the Big Bang Theory. We're talking about a single explosion around 20 billion years ago that was so massive, so incredibly violent that it honestly defies standard physics. From that one singular event, particles just rapidly expanded outward into the void. And as the universe expanded, it finally began to cool down. That cooling allowed gases like hydrogen and helium to form and eventually condense into the brilliant, swirling galaxies we see today, including our very own Milky Way.
Now take a second to really wrap your head around the sheer scale of geological time here. The universe sparks into existence 20 billion years ago, right? But our Earth, it doesn't even form until 4.5 billion years ago. And then it takes another 500 million years just for the very first organic monomers to even show up. From there, it's this incredibly slow march to acellular life around 3 billion years ago. And then finally, true cellular life at the 2 billion year mark. I mean, we are literally talking about oceans of time.
Moving on to part two, Earth's primitive atmosphere. Okay, so early Earth was absolutely not a hospitable place. We're talking about a surface plagued by scorching temperatures, violent volcanic eruptions, and just relentless massive storms. But you know what the most crucial missing element was? Free oxygen. Early Earth had what we call a reducing atmosphere, which was basically just a thick blanket of methane, ammonia, carbon dioxide, and water vapor. And here's the kicker. Because there was no free oxygen, there was absolutely no protective ozone layer. So what exactly happens when you don't have an ozone shield? Well, severe UV rays from the sun just struck the Earth completely unfiltered. They hit the water vapor and literally broke it apart into hydrogen and oxygen. Now, the lighter hydrogen, it just escaped straight out into space, but the remaining oxygen stuck around and combined with ammonia and methane to form water, CO2, and, eventually, that much-needed ozone layer. As the Earth slowly cooled down, all that water vapor condensed, and it rained, and rained. It rained continuously for ages, filling these massive depressions in the Earth's crust to create our very first primordial oceans. Which brings us to part three, the chemical origin of life. For the longest time, the exact origin of life was a total, complete mystery. Enter two brilliant scientists, Oparin from Russia and Haldane from England. They proposed this groundbreaking concept known as chemical evolution. They basically argued that the very first life forms didn't just magically appear out of thin air. Instead, they came from pre-existing, non-living organic molecules. And where did those come from? Inorganic molecules. Basically, their theory was that life was cooked up entirely through a very long series of chemical reactions sitting right there in that early ocean soup. Let's actually break down how that recipe worked. Remember those continuous, violent volcanic storms we just talked about? Well, the lightning from those storms acted as this massive, continuous energy source, repeatedly striking that inorganic molecular soup. This intense energy stitched those basic elements together into organic monomers. Think simple things like sugars and amino acids. Then, over extreme periods of time, high temperatures drove out the water, causing those monomers to bond and form complex polymers like RNA and proteins. This incredible chain reaction gave us our very first acellular life 3 billion years ago, which eventually organized into the first true cellular life 2 billion years ago. All right, let's look at part four, the Miller-Urey experiment. Now, theory is great, right? But science absolutely demands proof. So, fast forward to 1953, which is honestly a golden year for biology. A scientist named S.L. Miller, working under Harold Urey, meticulously built a closed glass flask system to perfectly recreate the harsh conditions of primitive Earth right there in a lab. He pumped in the exact same gases: methane, ammonia, hydrogen, and water vapor. He boiled the water at a scorching 800 degrees Celsius to simulate those extreme early temperatures. And to mimic those intense volcanic lightning storms, he actually installed tungsten electrodes to constantly fire sparks right through the gas mixture. Finally, he ran it all through a condenser to simulate the ancient nonstop rainfall. The result? Completely explosive. When Miller checked the liquid trap at the bottom of his artificial ocean, he found actual physical amino acids. Life's fundamental building blocks had literally formed from pure chemistry. And it didn't stop there. Later experiments tweaked the gas ratio slightly and managed to produce sugars, nitrogenous bases, and even pigments. We've even found these exact same organic monomers inside fallen meteorites, which pretty much proves that this type of chemical evolution is happening out in the wider universe too. Chemical evolution wasn't just a theory anymore. It was solidly confirmed. Next up, Part 5, Evaluating Theories of Life. It's important to remember that before modern science locked this down, humanity spent centuries debating a few other major theories. First, you had panspermia. This was an ancient Greek idea suggesting life arrived on Earth via spores from outer space. Interestingly, finding amino acids on those meteorites actually keeps the specific debate slightly alive even today. Then there was spontaneous generation, the kind of wild idea that living things just magically pop out of dead, decaying matter. And finally, special creation, which claimed the Earth was only about 4,000 years old and that biological diversity is fixed and never, ever changes. To give you an idea of how deeply some of these were believed, take the spontaneous generation myth. The great philosopher Aristotle literally thought that if you left a sweaty shirt in decaying mud, it would spontaneously generate living maggots. Just boom, maggots. But the famous scientist Louis Pasteur completely dismantled this. Using highly sterilized flasks containing killed yeast, he showed that in a sealed system, absolutely nothing grew. Zero. Life only appeared when he exposed the flasks to the outside air. Pasteur officially proved biogenesis, the fact that new life only ever comes from pre-existing life, not from a pile of rotting mud.
And finally, Part 6, Darwin and Natural Selection.
So while Pasteur proved where life doesn't come from, another scientist totally revolutionized our understanding of how life actually changes. Enter Charles Darwin. At just 22 years old, Darwin set sail on the HMS Beagle to map the world's coastlines. Through his intense, obsessive biological observations, he completely shattered the special creation theory. He proved that living organisms share deep similarities not just with each other, but with extinct, fossilized species. That meant mass extinctions had definitely occurred. He proved that biological diversity absolutely does change, that life forms show a very gradual evolution over time, and that the Earth has to be millions, not thousands of years old. When the scientific community challenged Darwin to explain exactly how this evolution happens, he gave us natural selection. It's a beautifully simple concept. In any population, you naturally have variations. Think of it like this. Imagine a room full of people where some happen to be incredibly fast runners and others are fantastic swimmers. If a massive flood suddenly hits that room, the environment, the literal nature of the situation has drastically changed. Nature is going to select the swimmers to survive, while the runners, well, they won't. Natural selection is just the environment favoring the variations that are best suited for survival at that specific given moment. But Darwin was quick to note that mere survival isn't actually the finish line. In biology, the ultimate measure of success is what we call reproductive fitness. Sure, you might have a favorable trait that helps you survive a harsh environment, but your true evolutionary victory is your ability to reproduce and actually pass that winning trait on to a larger number of progeny. Think about it. If an organism is struggling so hard just to stay alive, it's not going to reproduce. So leaving behind more offspring is the ultimate, undeniable proof that an organism is perfectly fit for its specific environment. Now, we really can't give Darwin all the credit here. Right around the exact same time, a scientist named Alfred Russel Wallace was working thousands of miles away in the Malay archipelago, which is modern-day Indonesia. Completely independently, Wallace arrived at the exact same brilliant conclusions as Darwin. He realized that, quote, the biological history of Earth closely relates with its geological history. Basically, the changing of life forms is locked in step with the physical geological changes of the Earth over these vast eras of time. In fact, their findings were so incredibly aligned that they actually presented them together. Which brings us to the end of our explainer. We have traveled from a 20 billion-year-old explosion down to microscopic organic monomers floating in a primitive ocean, all the way up to Darwin's grand theory of adaptation. But here's the thing. Evolution absolutely did not stop in the 19th century. It's a continuous, endless mechanism. So I want to leave you with this final provocative thought. If nature is constantly selecting the most favorable variations for survival, given our rapidly, wildly changing modern environment, what hidden traits is natural selection favoring in humanity today? Thanks for watching, and keep questioning the incredible world around you.